my first bit of advice for you on these also applies to yesterday's. It includes you understanding that what we're about to do is that we're going to factor this into two binomials. We're going to factor this into the same two binomials, right? Because they're the same. Both r squared plus 3r plus 2. And we have r plus 2. So it's understood that we are going to probably end up multiplying top and bottom by some binomial so that they're all the same. So as you write these down, keep that in mind. Give yourself space. More than anything else on these problems, if it's just sloppy or cramped, you may make mistakes that you would not otherwise make. So actually taking time to think about, well, let me create more space on this middle fraction because I know I need to add stuff in later is a really good idea. Really good idea. You know that we'll end up multiplying top and bottom by something, so it matches together. So take a minute. What does r squared plus 3r plus 2 factor? How's that factor? What do you get? R plus 2. You know this one's the same trinomial above. And then you can see, well, this one already has an r plus 2, so it's just an r plus 1. And again, if you wrote it properly at the beginning, you have plenty of space right now. We're not cramming this. This is overlapping with a minus sign, and then you can't see it, and you forget about it, and then you end up adding instead of subtracting. And everything's wrong simply because of spacing. Because at this point, we've done so many, we've gotten the mathematical mechanics that are pretty good. We're not making nearly as many mistakes that we've made in the past. So what's still in the way? It's that kind of stuff. It just doesn't matter. It doesn't make sense. All right. So same thing we did before. Multiply everything. Right? By r plus 1, r plus 2. All the way. And it's, if you look at the original problems and even the blank worksheet, this looks like a bunch of fraction problems, right? But really most of the time spent on these are no longer fractions. On the second step of all of these, as you saw yesterday, you cancel all the denominators out. So you're just left with whatever's on top. And this is just something from algebra 3 on 3 sometimes. Distributive property, variables on one side, numbers on the other. So that's a lot more basic than what we did this like. Alright, so we can solve this. Don't want to do that. Just go ahead and solve it on your own, see what you get, then check with me. And don't wait for me to do it, and you write it down and copy it and say, I'm done. Try it on your own, see if you can do it on your own, and then check to see if you get it. Then you get all the done. The last thing you want to do is look up, look down, copy. Look up, look down, copy. Not get better at by copying it down. Now I'm trying to get in shape by watching somebody else work out. You gotta do it yourself. Check one on both sides. 1 minus 1, 0. Okay. Okay. And we can check all this. Speaking of, since I'm having some doubts, why don't I just do a check real fast? I'll plug it in to see if it works. And since it's 0, it's a lot easier to plug in. Basically, anything in the variable is 0. So we're left with does 1 over 2 equal 4 over 2 minus 3 over 2. Is that true?
Yeah.
Yep. Okay. So I was there for no reason. That's the right answer. So you can see that's the same process you might do on a test. Like, I got this answer. I don't know. That seems kind of weird. Oh, wait a minute. You can know whether it's right or wrong right away. You don't have to turn it in. Hope I got it right. I don't know. Equations, you can always check. And with a 0, much easier to check. If this is a 1, I have to do 1 squared plus 3 times 1 plus 2. Feels a little bit more work, but still doable. But just to check the actual work here. This 4 over 2 minus 3 over 2 equals 1 over 2. Anybody can do this if your priority is accuracy. Alright, so let's try a few more. First step is always factoring. However, that first step, depending on what you have here, the factoring might be different. So here was the x, what multiplies the 2 and add the 3. But it might be something else, you might just do GCF. That's why I want to do 60. Because you might have do more than just that. So I don't want anybody thinking that, okay, the first step is the x, and it's the first step of factoring. It might include doing the x, but not always. Yeah, look at what's there and factor in the method that you need. So how do we factor all those on the bottom? Go ahead and do that. Again, leave some space for where you know you're going to be right one. First one factors 2. First one factors 2. Multiplies with positive 9 and 3. And a minus 3. How about here in the middle? What's the first thing? Yeah, exactly. GCF of 2. So again, if you say, oh, there's 3 things that just go straight into the x, but multiply with 36, that's well, again, that should be GCF first. And once you take a GCF out, what do you end up with? You end up with this, right? What's going to do that? It's basically the same thing. So we know it's another factor. The only way you'll come to that is if you look and notice the GCF. Same thing here, what's the GCF? Check it out. And of course, you should be noticing a lot of the same things showing up. If that's not happening, something's up. The idea is that these all have to be the same. You need a 2, an n minus 3, and another n minus 3. Okay, let's make it happen. Make a match. What do we need here?
2.
2. Yeah, there's 3 total. Only have 2 of them, so not fun. Right, just like it was with all numbers back in elementary school. Make the denominators match, multiply top bottom. What do we need over here?
And minus 3.
Another n minus 3. Top, bottom, they come back. And you gave yourself this. So. Alright. Now that we've done all that, we can cancel everything else out. All my geometry. That's the same. So that's at the top. 6. Equals. Do we know? Plus 1 times n minus 3, right? And I'll write it out. So you probably skip this stuff and I'll write it out. It's really distributing a 1 here. It doesn't change it, right? So it's the same as 1. 6 equals 1 plus n minus 3. And then solve the equation. Just like yesterday, the first 6 will be linear. There's no squares or anything down here when you're solving the equation, so you won't end up with anything squared on the top. But the second 6 problems on the back, you'll have quadratic terms on the top, so when you get down here, they may require factoring and solving and so on. Alright, so 6 equals 1, okay, 1 plus what minus 3 is 6. 1 plus what number minus 3 is 6. Solve it, see what you get. Try it out. So 1 plus 8 is 9. 9 minus 3 is 6. So that can work out. And if we did this like algorithmic style, we'd say 1 minus 3 is negative 2. Usually combine all the numbers on the same side first. Add 2 to both sides. Yeah, 6 plus 2 is 8. That's go. Check to see, just to make sure, they do mention in the initial corrections to check for extraneous solutions. So if you plug 8 in on any of these on the bottom, you get a 0. Okay. If you can't, you can also look at the factor version. So if you plug in 8 in here, you can see you don't get 0. The only way to really get 0 is if one of these was n minus 8. That'd be it. That'd be the way. So no extraneous solutions, so there's your answer. If we had to, we could check this. It'd just be a lot harder, right? 8 squared minus 6 times 8 plus 9. 8 squared times 2 minus 12 times 8 plus, you know, this is a little more difficult to check. So that's totally up to you. Depends on what situation you're in, how bad you're going to be to make sure it's right. So, given those two, how do we feel? You do more together, or are you guys just ready for work? Look at all the ones, look at all the on the back. Three. I'll get you started on it. Same thing. Go ahead and start factoring. Start factoring all those denominators. What's the thing you notice first? Oh, here we go. Leave a little more room for that first fraction. I'm going to leave more room because it's going to be that's 5. Leave a little room. That last one. Always comes back. But, there's a factor. got in the middle? What's that? Multiplies a negative 10, adds a negative 3. Good, and last 5, and plus 2. And hopefully you notice, compare these. What's the difference between them? Yeah, this one just has a GCF of an n. So once we take this out, it's the same as this. So my hope is that you don't just look at this and say, oh, that's a 3, that's harder, what do I do there? But that you look at these side by side and say, those are basically the same thing. N squared, minus 3, minus 10, n to the cubed, minus 3, minus 10. It's the same thing. Once you take out the n, they're identical. So not necessarily more difficult here. See how we're similar. All right, so we can see we have 3 factors for the GCF. We have an n minus 5, and an n plus 2. And we need all 3 of them in each denominator. So what are we missing here? N. So dot multiplied by n. Okay. And the last one, what are we missing? We're missing the n. And the n, and we're also missing the n plus 2, both of them. So it's okay that one of them is missing 2 factors. You're going to do whatever it takes to make all 3 of them. So denominators all the same. We're going to top and bottom when we need to. Let's get rid of them. That in, cancel them all out. And then here, it's all solving. Again, the last 6 are going to have quadratics. So you can see on the top here, we'll have n squared plus 2n. We'll have squared terms. And then plus, what is this? 5n squared. And then equals. Get that equal to 0. What are you going to do to both sides? Go ahead and solve it. You probably need to use the x of the box in order to solve it. You'll get it down to, eventually you'll get it down to 2 parentheses, right? And then once you get down to that point, just take each one of those, set whatever this is equal to 0, right? And whatever this is, and it's equal to 0. And then you'll get your 2 answers that way. And you will have 2 answers there. So go to your answer sheet, write it in the practice. I'll let you fill in just the solving part. The hard part here. So it's not too bad. Okay. You guys have a good over a half hour. Do remember you have a test on this on Thursday or Friday, some decide which day. And you have to take that test by yourself. And this is on there. So if you're not on any circumstances, sit with somebody, work on every little step together, or talking about every little step, and then say at the end, look, I'm done, I got it. When you really maybe haven't done any of it by yourself, and then when you get the test, then you realize, oh, I don't know this. So try it on your own, but definitely okay to check. Okay? Don't be dependent on somebody, making sure everything's step by step perfect. I'd say do one problem, check to see if it's right, do another, check to see if it's right. If you get stuck, don't erase everything, see if you can find the error, call me over, see if you can find the error, but don't just erase it all and say, oh, I don't get it. I'm going to tell you, okay, try it again. I'll find a mistake, but we're not going to go through every little step together. You have to do